that is properties of complex numbers. Now define the complex number, that is z is equal to x plus iy is any number. This x is called the real part of z, that is x, and this y is called the imaginary part of z, that is y. Now mod of z is defined as mod of z is equal to root of real part of z to the power 2 plus imaginary part of z to the power 2. That is mod of z is equal to root of x square plus y square. Conjugate of the complex number. Conjugate of the complex number is defined as z bar is equal to x minus iy. We place minus I in the place of I. So we get the conjugate of the complex number. So z is equal to x plus iy. So z bar is defined as x minus iy. Mod of z is defined as root of x square plus y square. Here we can see real part of z is always less than mod of z, because x will always be less than root of x square plus y square. Similarly, imaginary part of z is always less than mod of z, that is y is always be less than equal to root of x square plus y square. Now, properties of modulus. There are 4 properties of modulus. First one is mod of z1 into z2 is equal to mod of z1 into mod of z2. Second one is z1 by z2 whole mod will be defined as mod of z1 by mod of z2. Third one is mod of z1 plus z2 always be less than or equal to mod of z1 plus mod of z2. You can extend this property further, that mod of z1 plus z2 plus z3 up to zn will always be less than mod of z1 plus mod of z2 plus mod of z3 till mod of zn. And fourth one is mod of z1 minus z2 will always be greater than equal to mod of z1 minus mod of z2 whole mod. First two properties, that is mod of z1 into z2 is equal to mod of z1 into mod of z2. The last two proofs will be taken up when we will teach you polar form of the complex number. We take z1 is equal to x1 plus iy1 and z2 is equal to x2 plus iy2. z1 into z2 is equal to x1 plus iy1 and z2 is equal to x2 plus iy2. If we multiply z1 and z2, you will get x1 x2 plus I square y1 y2 plus x1 y2 plus x2 y1 into I, that is x1 x2 minus y1 y2 plus I times of x1 y2 plus x2 y1. Mod of z1 into z2 will be root of x1 x2 minus y1 y2 to the power 2 plus x1 y2 plus x2 y1 whole square. So mod of z1 z2 will be equal to root of x1 square x2 square plus y1 square y2 square minus 2x1 x2 y1 y2 plus x1 square y2 square plus x2 square y1 square plus 2x1 x2 y1 y2. This term will cancel out. So in the bracket you will get x1 square x2 square plus y1 square y2 square plus x1 square y2 square plus x2 square y1 square. So we'll get x1 square plus y1 square in one bracket and x2 square and plus y2 square in second bracket. So we will get root of x1 square plus y1 square into root of x2 square plus y2 square. This term can be written as mod of z1. This term can be written as mod of z2. So mod of z1 z2 will be equal to mod of z1 into mod of z2. Now we come to the property second, that is mod of z1 by z2 is equal to mod of z1 by mod of z2. Again we take z1 is equal to x1 plus iy1 and z2 is equal to x2 plus iy2. z1 by z2 will become x1 plus iy1 divided by x2 plus iy2. First we write z1 by z2 in a proper form of a plus ib. we write z1 by z2 in a proper form of a plus ib. So z1 by z2 will be written as x1 plus iy1 divided by x2 plus iy2. We rationalize the denominator, so we multiply x2 minus iy2 and x2 minus iy2 in numerator as well as in denominator. So z1 by z2 is equal to x1 plus iy1 into x2 minus iy2 divided by x2 square plus y2 square. Now z1 by z2 will become x1 x2 plus y1 y2 plus I times of x1 y2 minus x2 y1 divided by x2 square plus y2 square. So z1 by z2 can be written in a plus ib form as x1 x2 plus y1 y2 divided by x2 square plus y2 square plus I times of x1 y2 minus x2 y1 divided by x2 square plus y2 square. Now if we take the mod of z1 by z2, it will become root of real part of z to the power 2 plus imaginary part of z to the power 2. So this will become x1 x2 plus y1 y2 upon x2 square plus y2 square whole square plus x1 y2 minus x2 y1 divided by x2 square plus y2 square whole power 2. By solving it, we will get root of x1 square plus y1 square in the numerator and in denominator x2 square plus y2 square. So it will become mod of z1 by mod of z2.